We are going to do a circuit with Verilog, and we've got 2 multiplexers, and they're both 2-to-1 multiplexers. Notice that the top multiplexer, we have 2 inputs, S0 and S1, that are both 1 bit. Our bottom multiplexer, we have a vectored signal, so that's 2 bits wide, so cell 1, 0, that's just telling us that this cell is defined as a vectored variable that's 2 bits wide. And so I'm not going to type all of it out, I'm just going to do the good stuff. So it'll start with module and all your inputs and outputs. So A comma B dot dot dot. So I'm not going to do that part. And then your inputs would be A, B, C, D, E, F, G, S0, S1, and cell, SEL, and your output is just going to be Y. You just have a single output Y. And actually, I'm not going to put cell here because I need to define it as a vector. So I'll put input cell input 1:0 cell semicolon. So that defines it as a 2-bit vector. And Y, I'm going to define it in always block, so I need to put a reg in there, output reg Y. And then I'm going to have an intermediate variable in here. I'll call it T. So I'll have reg T. And I'll have 2 always blocks here. So I'll have always at, and this will be my top always block, A, B, C, D, S0, S1. And then I'll have a case statement, and you put in parentheses the thing that's like if whatever, the thing that has the different values, and I'll do it like I did before, S0, comma S1. You could do this as some nested ifs. If S0 equals 0, then if S1 equals 0, but case statement's a lot easier. I'm going to list my case statements slightly differently this time. Rather than putting them as decimal numbers, I'll put them as their binary values. So 2'B00. So that means it's a 2-bit binary number, 00, colon. And if if S0, S1 is 00, then I want T to equal A. And then 2:B01, or 2' T equals B. 2'B10, T equals C. And 2'B11, T equals D, semicolon. Now, for fun, I'm going to just go ahead and put a default in there, and I'll say T equals A, and yes, I do have a typo up here. That should have just been T equals A. T equals A. Now, the reason I put a typo in, put a typo in because I made a mistake. But the reason I put a default in is when you start doing your Verilog, sometimes your always block, you might have your case statement, it might have variables in it, and Verilog won't necessarily know that you've covered every possibility. You'll know you've covered every possibility, but it might not know if these are not just numbers. And so it's going to it'll throw an error at you until you put a default in there. You have to say you have to have everything taken care of. You have to have every possibility taken care of. And then I'll have end case. And I'll end this always block, and then I'll start another always block, always at, and this always block will be T, comma, E, comma, F, comma, G, comma, cell. Yeah, I want to do that. Okay. And then begin. Do I need a begin? I don't need a begin. So I didn't need an end for this always block here because I didn't begin it. And I don't need a begin here either. And I'll have case. And this time I can just put cell. I don't have to put any curly brackets because it already is a 2-bit number. And this time I'm going to be lazy and use the digital values 0, colon, y equals t, semicolon, one colon, y equals e, semicolon, 2 colon, y equals f, semicolon, and 3 colon, y equals g, semicolon, end case, end module. We're done. Any questions on that?
There's a way you initiate this matter of you 0, 1, or 1, 0, the input in the beginning.
Right here?
Yeah.
Okay.
So you want to mark it.
Does it matter if I do 1, 0 or 0, 1?
Yeah.
So this is saying where the most significant bit is. So what 1, 0 means is that means that my most significant bit comes in front. So that means that 1, 0 equals 2. It means that this is the 2's place and this is the 0's place. If I had done input 0, 1, then that would mean 0, 1 would equal 2, that this is the most significant bit and this is the least significant bit. And so that's going to be important when you start using your when you program the basis board, to make sure that, like, if there might be a time that you have like this whole pattern of bits that you want to use, and so for whatever reason, and if you want to write it like that and think about it like that, then this would be 0, 1, 2, 3, 4, 5, 5 to 0. But if you wanted it to read the other way, you do 0 to 5.
So
But
how does that compare to, like, in the first case statement where you do S0 and then S1?
I would, if I wanted it the other way around, I would have put S1, comma S0. So this corresponds to S0, like this value right here means S0 equals 1 and S1 equals 0. But if I had written it like this, S1, comma S0, then this value would correspond to S1 equaling 1 and S0 equaling 0.
So is there any way to tell, like, which direction you're supposed to use from the circuit they give us, or is it just,
No, it'd be what how the multiplexer was set up, yeah. So no, there's not. And I get confused myself, I don't always know which way it goes, and I mean, on this instance, I could say, well, I don't have the data sheet for the multiplexer, so how do I know? I just made it up. And that's how you would know, you'd look at the data sheet for the multiplexer. Other questions? Okay, well, I have to go, so I am going to stop everything.